Hi there. In front of you is probably my favourite Roberts radio. It's an R900, and although it's a fairly modern radio, I think dating from about 1985, though I'm not too sure about that, I think it's the best of the Roberts, which is a bit controversial to say. But this one gets used daily, and it's a radio I probably wouldn't ever sell. It's got what's it got? Well, it's got the usual long, medium and VHF. Got bass and tone controls.
We were just fighting the lack of national response.
Anyway, and it's got loads of volume. And of course it also runs on mains as well as batteries. And I had this on the bench a few days ago, and I thought, after all those years, 30 something odd years, perhaps it could do with some new capacitors. Give it a nice birthday present of new capacitors. But when I took it all apart, I took out some of the capacitors to check them, and they were absolutely perfect. In fact, the 1000 microfarad, which is in the power supply section, was better than the one I was going to replace and put in there, which is a brand new capacitor. I think it's a Panasonic as well, that was, I was going to put in there. So I thought to myself, it doesn't need new capacitors, nothing wrong with this at all. So it will go on with the old capacitors as for a few more years, no doubt, probably till the day I die, which probably isn't going to be long the way things are going. But never mind, I'm only joking. But when I was looking up information on it, it interestingly says it will produce 1.5 watts on batteries and up to 5 watts audio output when it's running on the mains. And I thought, well, it's quite a high power figure, isn't it? Be interesting to check that. And when I had it apart, I noticed that you're getting only 9 volts on batteries, of course, but the power supply produces 16 volts, so it's a considerable increase over the battery power, so hence the fact that it could be capable of high power. So what I wanted to do in this video is actually measure the power before you get too much distortion. Yeah, and just generally see if it can produce the full 5 watts. So in order to do that, I'll have to disconnect the speaker and run it into a dummy load, and then look at it on the oscilloscope, and maybe even the HP audio analyzer to see what distortion's like. And what I'll do is I'll inject a signal, well, I'll produce a signal on my signal generator, which will be connected to a short whip aerial, 1 kilohertz tone modulated FM, and then I'll pick it up via the RF section of the radio, and then I'll measure the distortion and the power output. So I'll just get the back off it, bottom off it, and disconnect the speaker wires and connect them up to a dummy load. So what I've done is I've connected the audio output to dummy load, and it turns out the speaker is actually 4 ohms. There's a dummy load over there wired up. There's actually 2 sets of 8 ohm resistors which I've paralleled up to get 4 ohms, because I would normally use that to check left and right outputs at 8 ohms on an audio amplifier. As in this configuration, they're parallel to give you 4 ohms. And I'm up on my signal generator. I don't know if you can see that, probably not. Anyway, I'm transmitting a signal on 100 megahertz, 0 dBm into short whip aerial with a 50 kilohertz deviation and 1 kilohertz modulation, FM modulation. So now we go round to the scope, which is not easy for some reason. At the moment, I really ought to sort something out better than this. At the moment, what am I getting? This is not fully turned up at the moment, but it's 800 millivolts roughly RMS at 1 kilohertz, and if I detune the radio you'll see it come down into the static. That's peaking at 100 megahertz, which strangely enough lines up exactly on the dial at 100 megahertz, so that's always a bonus. So now what I'll do is I'll crank it up till I get some distortion. Crank it right up, and there we get a bit of distortion, just about there, and I'm reading now 3.3 volts RMS. I turn it down so it doesn't blow the amplifier transistors up. So now I've got to do a calculation. Now what do? I want to do, lost my calculator. No, I don't want tan. So what was it? 3.3 volts RMS. Square that and divide that by 4 ohms. 2.72 watts. So it's not producing 5 watts at all. Oh well. I think 2.72 watts is still pretty bloody loud though on a radio. I don't think you'd want to turn it up at that volume. You'll probably get a lot of speaker distortion at that volume. So I think next thing to do is to connect up the audio analyzer and see what that thinks of it. So I just turn that on. It's the audio analyzer booting up. I've got to now connect a wire, a cable across the dummy load to the input of the audio analyzer. Right, audio analyzer is now connected, and as you can see it's measuring 0.9241 volts, and my scope's gone off. I want my scope on at the same time. And what do? We measure press distortion. So that's with the volume not turned the whole way up. So we're already getting 7% distortion. So if I crank the volume up to get to the peak output before distortion, oh well, it's a bit unstable. Wonder why it's so unstable. Okay, well 2%, that's a maximum volume at 2.7 watts. And we can actually measure watts on the audio analyzer if I remember how to do it. Special function. Special, I think it's 2008 special. Oh well, that's not right. Forget that. Just AC level. Okay, special function 2008 special. No, I need to read the book. Just pause this. Right, I worked out how to do it. You've got to do 19.04 special. Now it should read the wattage as I got it turned down. It's going to be fairly, it's 400 milliwatts. So if I crank it up a bit, it's just about coming into distortion. So reading 3.5 watts compared to what I was calculating at 2.7. I think I'd be inclined to trust this thing more because it's HP, and you never disagree with an HP. So 3.5 watts, not too bad though. So that's pretty good. Now I want to go back and measure distortion again. 5%. Seems strange that it's got less distortion at low volume, more distortion at low volume I mean, because I'm on low volume at the moment and it's 6%, and I crank it right up to clipping, it's 3.3% distortion, or even 2.4% distortion. Yeah, it seems to have more distortion at lower levels. I crank it right up again. Well, whatever, it's an interesting test. So 2.3% is not too bad a level of distortion, I guess, because you've not only got the distortion of the audio amplifier to take into account, you've got the distortion of the FM circuit as well. And if I was just going straight into the audio amplifier, I might record a lower level. Anyway, this poor radio has been running now at 3.7 watts, I better turn it down again. And well, it's just an interesting little test really, to see if the Roberts R900 could do 5 watts. Obviously it can't quite manage it, but I still think it's pretty good to produce that amount of power really. So that's about the end of the video, so bye for now.